One of the things we have to do with our LCD display here is the cable that comes from it. We have to cut the red wire here and have it come to another connector. Now what I've done here, this is just a very simple connector, and the problem that you run into here is this is braided wire. So it's a little harder to connect. So what I've done is I've just taken the braided wire, pushed it around this connector here, and to make a solid connection, what we really need to do is melt some solder on this connection between the braided wire and the straight wire that we've got here. Once we have a solid connection, we can just plug this into the 5 volts on our header here, and we've got our LCD properly connected. The LCD is an I2C device and can be plugged into any of these 4 I2C connectors. To avoid conflicts in hooking up devices to one of the 4 I2C connectors, each one of the I2C devices has their own individual I2C address from 00 to 0F, 10 through 1F, and so forth. And what you're going to find, for instance, here we have 2 different devices listed here. But if we click on 6-axis compass, we can see that this is discontinued. And chances are you're either going to buy the 3-axis or have the 6-axis. You're not going to have both at the same time plugged into one of those I2C connectors. Now if we look down here, we can see that address 3E is our LCD, but also 6.2 is our LCD. They're different addresses, so there won't be any conflict here. So any one of those 4 slots can take any of these devices without any conflict, because each of these devices has its own internal addressing scheme. When we start writing programs for the LCD, besides including embed.h, we're also going to have to include Grove LCD RGB backlight.h. Also, we're going to have to specify where our pins are for I2C, which happens to be pins D14 and D15 on our UNO connector for our Freedom K64. The functions that are available for our LCD are set RGB, which allows us to set red, green, and blue levels, and if they're all set to maximum, you get white, and that's the highest contrast for black characters that you're going to print using the print command. Now we also have locate, which allows us to specify where on our LCD we want to place our text, column 0 and row 0. So columns go from 0 to 15, rows go 0 to 1. So it's printing up 2 messages, and then it's going to have this message held on a white background for 5 seconds. Then it's going to change for a red background for 1 second, a green background for 1 second, a blue background for 1 second, and it's going to continually flip, as you can see here. What we want to do is include a write function, which does not exist in our library at this point. For instance, if we want to take 2-digit values like A, B, or in this case 3A from a device and display them as a 3A, it's not capable of doing that with the functions that exist right now. So that's why we're going to add our write function. Now 3a, if we remember, 3 times 16 is 48 plus 10 is 58. If we couple our write function with a function called hexadecimal, we can have, instead of 3a, we can actually have 58 and show the BCD value of this as well. So those are some of the things that we can do. Now the write character function just writes an individual character, but let's see how we're going to implement these inside our library. The fastest way to get started programming the LCD is to simply, in the Cloud Compiler, do an import programs and search for Grove LCD. When you double click on this particular one here, it's going to load in here Grove LCD RGB backlight hello world. Now this has classes, so if we just double click here, we can see a list of the classes that are in here already, and we can see the main.cpp. Now this one I've actually added extra comments to, as you can see in the notes. But one of the other things is that mentioned in here is you have to go into the backlight.cpp, and it doesn't particularly matter where, but somewhere in here you're going to have to copy in the write function and the write character function in here. The other thing that you have to do is to go to the Grove LCD RGB backlight.h file, and as long as you're in the public section here anywhere, I'm just going to put it down at the bottom of the public section, you should be able to then put in the 2 function prototypes for write and write character. Once you've done that, we're going to say save all, And the beauty of that is at any point now we can go here, right mouse click and say clone, and any file we can rename it anything we like. We're just going to leave it as copy now, but if we go here and take a look at our copy and go down to our Backlit CPP file, we'll find in here the same write and write character function that we had, and we'll also find in here at the bottom of public we will find our write and write character function definitions. So once you've created this, you only have to do it once, and you can rename this anything you like and use this for any program that you have as the main.cpp file. Now we can take this program on page 72 and load it into our cloud compiler. And when we do, we can see at the bottom here our unsigned hexadecimal code. Now when we run the program, what you're going to see is a temperature coming up. And if we take a look further up here, the hexadecimal of temperature will give us our degrees Celsius. The other hexadecimal temperature further down here will give us our Fahrenheit degrees here. Now, one of the things you can try is to take out the hexadecimal here and the hexadecimal there, and you'll see these values coming up in hex, not in BCD. Now, if I put my finger over the temperature sensor, we can see the values increasing. If I was to hold this against something cold, you'd see the temperatures decreasing. Now you'll see over here as well, what we have here is the equal sign here, which shows up in this position here. And so all of the stuff that's here, the DF that's here, is the degree symbols both here and here. As we saw on the PC screen, that's F8, but here it's DF, so the alternate characters are indeed different.